Okay, so let's proceed to graphing trigonometric functions. But before we do the graphing proper, let's first have the standard form of equation of a trigonometric function. It's given as y equals a sine b, x minus c plus d. So a sine function here is just an example. If we want it to be a cosine function, simply change this to cosine. Alright, so this is the standard form. So let's discuss what are these variables for, what do they stand for. So first, let's have the variable a. The variable a here gives us the amplitude. So for us to solve for the amplitude, whatever number we have here, let's say it's positive 3, we get the absolute value of positive 3, and that will give us 3. So the amplitude of that function will be 3. If it is negative 3, we get the absolute value of negative 3, and still we will get 3. So the amplitude of our graph will be 3. So that is an example. So in this case, in my example here, the amplitude I've written is 3. So whether this be positive or negative, we identify the amplitude as the absolute value of this number. Clear? But by the way, we know the amplitude tells us the height of the peak or the depth of the trough from the center line. So technically, with the transformations of graph, it's like our vertical stretch or vertical compression. Alright, so let's proceed to the next variable, the variable b. The variable b here is like our horizontal compression or horizontal stretch. So we know that graphs of functions transform from the parent function. So we know that from the parent function of a sine function, the period, one period is 2 pi, right? So the parent function of a sine function has a period of 2 pi, but once there is a number that exists here, that will affect our period. Thus, we could have a horizontal stretch or a horizontal compression, and that period we could solve by having this formula, 2 pi over b. So in this case, in our example, we have y equals 3 sine 2. The number we have here is 2. So meaning we will have a horizontal stretch or compression. In this case, if we use the formula 2 pi divided by 2, our period will become pi. So imagine if we have this graph which has a period of 2 pi, if we'll just have a period of pi, then it will become like this. Right? It will become smaller. So our graph will horizontally compress. So that is what this number 4. It will give us the horizontal stretch or the horizontal compression, and it transforms our period from the parent function, which is 2 pi. Okay? So take note of this formula. Next, the variable x that we have here. The variable x here actually pertains to the angle theta. In some references, they still use theta in representing this standard form, but for us, we'll use x instead. Okay, now let's go to the phase shift. So we know that the phase shift is the horizontal translation or horizontal shifting of the graph of a trigonometric function. So it's given as the variable c. Take note that if the expression we have here is x minus c, even if this is negative, it doesn't mean that we will move to the left. It's the opposite. It's the other way around. If we are given x minus c, we'll then have c units to the right. We'll move c units to the right. If it is x plus c, we will move c units to the left. Okay, is that clear? Now, this variable c here is actually usually given as a value in radian measure, just like this example. Okay, if you will remember from our previous video, the values on the x-axis are actually in radian measure. Those are still considered real numbers. It's just that they're not in decimal form, but in radian measure. Okay, take note, x minus c, c units to the right, x plus c, c units to the left. So that's how our phase shift will go. Lastly, the vertical shift. The vertical shift is given as the variable d. If this is positive d, it means that we have a vertical shift going up. Okay? A vertical shift going up. If it is minus d, meaning our vertical shifting will be going down. Just like in our example here, it's minus 1. So we will go 1 unit down. If it is plus 1, we will go 1 unit up. Okay, is that clear? If it is plus 2, you will vertical shift 2 units up. If it is minus 2, vertical shift of 2 units down. So, since we're done discussing these variables, these properties, let's do graphing. Let's start with a sine function. Alright, let's start graphing. First, let's have the parent function of sine. It is y equals to sine x. Okay, so this is our parent function. When we say parent function, meaning there are no transformations yet, there are no translations or stretching or compression that has happened yet. Okay, so how do we graph the parent function? So I'm going to show you how to graph the parent function, because of course that will guide us how we will actually graph a trigonometric function, even if there are already transformations existing in the function. So first, let's identify its properties. Its amplitude, of course, the coefficient here is 1, so that is our amplitude. Amplitude is the absolute value of that number, which is a, and absolute value of 1 is 1. So meaning the height of our wave should be 1 unit from the center line. And then for our period, we know that a trigonometric function has a period of 2 pi. Okay, a complete period of 2 pi. And then for the phase shift, since there is no transformation yet that has happened because it's a parent function, our phase shift is none, vertical shift also none. Alright, so how do we graph a sine function? So first, let us consider our period. Okay, so how many periods are we talking about? In this case, our period is 2 pi, meaning if we're going to start from the origin, our wave will reach until 2 pi to complete 1 period. Okay, so from the origin until 2 pi, it's counted as 1 period for our parent function. Okay, so we'll start here. We know that the graph of a sine function looks like that. Okay, and it starts from here at the origin, and then we expect to end here on the y-axis at 2 pi. Okay, next we need to divide this segment into 4 partitions. Okay, so since these are already divided by 2 parts, we can easily make 4 partitions out of it by getting half of this and half of this. Okay, so we already have the 4 partitions that we need. 1, 2, 3, 4. Okay, so our first point to consider is this, the one that we're starting from, and then we're gonna end here. That is what we're expecting. Okay, next, our amplitude is 1. So how do we identify where the next point of the graph will be. So we divide it to 4 partitions because that will serve as our guide where the points should be. Okay, so take note that the peak of the wave is actually here. Okay, 1 unit up from the center line. Okay, at katapat niya to, the first partition of the segment that we divided into 4 parts. Okay, and then we know that our graph will go up there at the peak. I'm gonna make a V again, and it will go up there. Alright, and then we know that the graph will go down. Go down where? Here, here, or anywhere. The next point will be there, at the second partition. Alright? Okay? Next, for our throw, it's just like the peak. If the peak, tinapat natin siya here, for the throw, we'll also do the same. It should be 1 unit from the center line. So it should be like parallel to -1. Okay, and then connect, and then finally we'll go to 2 pi. Alright, so do you see the pattern? Center line, go up to the peak, go back to the center line, go to the throw, and then go back to the center line, and you are done. Okay, so now let's apply some transformation with our graph. From the parent function, now we're going to graph y is equal to 2 sine x. So obviously there is already a change, especially with our amplitude. So our amplitude is the absolute value of 2, so it gives us 2. Of course, the height and the depth of our graph, of the wave of our sine function, will change. The period is still 2 pi. And then the phase shift is still none. Vertical shift, still none. Okay, so how do we graph this if there is already a change with our amplitude? So again, let's start from the origin. Okay, next, we'll go up 2 units from the center line to the next point. But before we do that, considering that we have a period of 2 pi, so we're going to cover the segment. First, let's divide it to 4 partitions. Okay, then from the origin, you need to go to the peak 2 units from the center line. So it is parallel to this coordinate. Okay. Next, we'll go up there. Next, go back to the center line. Alright, then 2 units down from the center line. -2. And then go back up to the center line. Okay, so recently our amplitude was 1, so it just had a certain height, which is 1 unit from the center line, but in this case it's already 2 units from the center line. Okay, what if there is a negative sign before it and there is a change in the amplitude? Is there a change in the amplitude? No. The amplitude is still the same, even if the leading coefficient, even if the coefficient here is negative. Okay, but what will change is, of course, the graph, because it will flip across x-axis, but the amplitude is still the same. So basically, this graph that we've drawn will reflect across x-axis. So I'm gonna make it a traced graph. Okay, so it looks like a DNA now. Okay, so my drawing is not perfect, but I hope you understand how to do it. Okay, alright. By the way, these ticks that we've made are not just merely ticks. Okay, the partitions made us do this ticks, which is meant to signal us that it's divided into 4 parts, but those are not merely ticks. Those are coordinates. Okay, so if you were asked what is the point, what is the coordinate of this throw right here, it must be pi over 2, comma, negative 2. Now, if you are asking, Mom, why did it become pi over 2? Of course, if this entire segment is 1 unit, half of it is 1/2 pi, or pi over 2. From pi, if you're gonna add another half of pi, or 1/2 pi, it will give us 3 pi over 2. And 3 pi over 2 plus pi over 2 will give us 2 pi, so on and so forth. Okay? 2 pi plus pi over 2 will give us another coordinate here, which is 5 pi over 2. Okay, adding another pi over 2, okay, will give us 6 pi over 2, which is 3 pi. Adding another pi over 2 will give us 7 pi over 2, and another pi over 2 will give us 8 pi over 2, or simply 4 pi. So I know that these coordinates, the graphing paper, the graphing sheet will be, the Cartesian plane will be given during the test, so you don't need to worry how to actually put these coordinates. But please take note of this, because you should know how to do it. Okay?